Hello everyone, welcome back to Topper Sutra. Today's concept is ray optics. Before starting ray optics, what is mean by optics? Optics is the branch of physics in which we study the behavior and properties of light. Okay, so what is optics? The branch of physics in which we study the behavior and properties of light. The light is the part of the electromagnetic waves which gives sensation of vision. Okay, so light is the part of electromagnetic waves which gives sensation of vision. Okay, light travels along a straight line with enormous speed of 3 into 10 power 8 meter per second. So light travels in the vacuum speed of 3 into 10 power 8 meter per second. It means in 1 second it can travel 3 lakh kilometers. Clear? So if you see the electromagnetic spectrum, like I am writing from high frequency range to low frequency range: gamma rays, X-rays, UV, after that visible, infrared, microwaves, radio waves. Okay, so frequency range gamma rays to radio waves, the frequency is decreasing, meanwhile the wavelength is increasing. Okay, so this is the electromagnetic spectrum: gamma, X-rays, UV, visible, infrared, microwaves, radio waves. So we cannot see all the radiation. We can see the radiation which lies between 400 nanometers to 750 nanometers. Okay, so 400 nanometers to 750 nanometers. So the wavelength which is in between lies between 400 nanometers to 750 nanometers, that radiation, okay, we can see only that radiation. Is it clear? So that is called visible light, and it has 7 colors. The white light has 7 colors: violet, indigo, blue, green, yellow, orange, red. Okay, so Vibgyor. So we can see only this light, so that's why this is visible light. And before 400 nanometers and above 750 nanometers we cannot see, so that's why it is not visible for our eyes. Okay, so we can see only this range which is lying between 400 nanometers to 750 nanometers. Is it clear? So now we will understand the properties of light. Light carries both momentum and energy properties of light. The first one is light carries both momentum and energy. The second one is light is a electromagnetic wave. Okay, what is light? Light is a electromagnetic wave. Light is associated with both electric and magnetic fields. Is it clear? Light is associated with both electric and magnetic fields, and it is transverse in nature. Transverse in nature. And the third one, the speed of the light. The speed of the light in vacuum is 3 into 10 power 8 meter per second. Is it clear? Okay, so the speed of the light in vacuum is 3 into 10 power 8 meter per second. So it is the speed is extremely large in the case of when it travels in the vacuum or in free space, and the speed of light can be calculated by using the simple formula V is equal to frequency into wavelength. Is it clear? So V is equal to F into lambda, and this is the extreme speed of the light. Okay, so the light is a electromagnetic wave and it is in transverse in nature. So what is meant by transverse? When light is traveling, okay, so the direction of the propagation is perpendicular to the direction of the vibration. See here, the light wave is traveling like this. Okay, so in which direction it is propagating? Along the x-axis. In which direction it is vibrating? Up and down. Okay, along the y-axis. See, what is the angle between them? 90 degree. Is it clear? So if the direction of propagation is perpendicular to the direction of vibration, then that wave is called transverse wave. Is it clear? So light wave is a electromagnetic wave and transverse in nature. So the speed of the light is 3 into 10 power 8 meter per second. It is extreme speed, and the speed of the light can be calculated using a simple formula. Speed is equal to frequency into wavelength. Is it clear? So rectilinear propagation of light. What is rectilinear propagation of light? Light travels along a straight line, not a curvy, not a wavy, while it is traveling in the uniform medium. Okay, clear? So what is rectilinear propagation of light? It travels in a straight line. Okay, so not curvy or wavy. When it is traveling in a uniform medium. Is it clear? So let us understand the simple terms ray and beam. Okay, so what is ray? Ray is represented like this. Okay, so ray is the straight line path of transfer of light energy. Okay, so what is ray? The straight line path of transfer of light energy, and the ray is indicated like this. This arrow symbol represents the direction of propagation of light. Okay, ray is the straight line path of transfer of light energy, and the beam. So beam is what? Beam is the bundle of rays together is called beam. Okay, so this is beam, and it can also be a beam, and it can also be a beam. Clear? So beam is what? The group of rays together. The group of rays. And beams are three types: parallel beam, diverging beam, and convergent beam. Okay, so let us understand what is parallel beam, what is convergent beam, and what is divergent beam. Okay, so parallel beam is, here see, the light rays are parallel to each other and the light rays are going in the same direction while maintaining a constant separation from each other. See here, look at the rays of light. All the light rays are going along the same direction while maintaining a constant separation from each other. Okay, so this is called parallel beam. What is this? Parallel beam. So all the light rays are going in the same direction. And look at this. This is divergent beam. Divergent beam. So in this divergent beam, see, the group of rays, the group of light rays are spread out from each other. Okay, and they appear to originate from the point, okay, a single point, so that is called virtual focal point. Okay, so in divergent beam the group of rays are spreading out from each other, okay, and they appear to originate from the common point, so that is called virtual focal point. Okay, so virtual focal point, this is virtual focal point. Okay, and look at this, this is convergent beam. Convergent beam. So in this convergent beam, the light rays are, see how they are, the group of rays are coming from various directions and they are meeting at one point. See, so this point is focal point. Clear? Focal point. So a group of rays are coming from various directions and they are going to meet at one point. Okay, so that is called focal point. Okay, clear? So you understood the difference between parallel beam, divergent beam and the convergent beam. So optics, the wavelength of the light is negligible when compared with the dimensions of the obstacles. Okay, so here in this ray optics, wavelength of light is negligible when compared with dimensions of objects. So what we take in the ray optics? Objects like mirrors, lenses, prism, etc. Okay, here we study the phenomenon by taking the light rays, reflection, refraction and total internal reflection. Okay, taking the rays of light we can explain reflection, refraction and TIR. Okay, and coming to the wave optics, here wavelength of light is comparable to dimensions of objects, and here it can explain diffraction, interference and polarization. Clear? So in ray optics we study reflection, refraction and total internal reflection. In wave optics, diffraction, interference and polarization. So in wave optics, wavelength of the light is comparable to the dimensions of the objects, and here wavelength of the light is negligible when compared with the dimensions of the objects. Okay, so now let us understand reflection. What is meant by reflection? So when light rays strike the boundary of two media, some part of the light is turned back into the same medium. That is called reflection. In simple words, the reflection is bouncing back of the light into the same medium. Okay, so I am taking a perfect reflector, that is mirror. Okay, so other than mirror, if you take any other surface, it reflects some of the light and it absorbs some remaining amount of the light. Okay, so if you take the mirror, it reflects back into the same medium, like most of the light get reflected back. So see, this is a mirror. Okay, so this side is silvered surface and other side will be a reflecting surface. Now I am taking a single light ray, it is falling on the mirror, and then what happens, this mirror reflects back in other direction. Okay, so the light ray which is incidenting on the mirror is called incident ray. the light ray which is coming back from the mirror is called reflected ray. Reflected ray. Okay. So to measure angle of incidence and angle of reflection, we have to take the normal. Normal is a line that is perpendicular to the surface. Okay. So we have to take the normal at the point of incidence, point where the incident ray is meeting the mirror. At that point we have to take the normal. Okay, so normal is a line which is perpendicular to the surface. Now the angle made by the incident ray with the normal is angle of incidence, and the angle made by the reflected ray with the normal is angle of reflection. Is it clear? So you understood what is incident ray, reflected ray, normal. Okay, so incident ray is, now you understood what is incident ray, normal and reflected ray. The incident ray is the light ray which is incidenting on the surface is called incident ray. The ray which is coming back, okay, reflected back from the mirror, that is reflected ray. The line which is perpendicular to the surface is called normal, and the angle between incident ray normal is called angle of incidence. The angle between reflected ray normal is called angle of reflection. Is it clear? So now we discuss about laws of reflection. Laws of reflection. What are the laws of reflection? According to first law of reflection, angle I is equal to angle R. So angle of incidence is always equal to angle of reflection. Okay, always is equal to angle of reflection. Angle of I is equal to angle of R. And the second one is incident ray. Incident ray normal at the point of incidence, and the reflected ray all lie on the same plane. Clear? So incident ray, normal and the reflected ray all lie on the same plane. Okay. Note, these laws of reflection are always valid on all types of reflecting surfaces. So note is, the laws of reflection are valid for all reflecting surfaces. Types of reflections. So the first one is regular reflection. Regular reflection, this is also known as specular reflection. Specular reflection. So in this reflection, this reflection takes place on the highly polished surface. Okay, so highly polished surface, and we are incidenting a parallel beam. So parallel beam. So at the point of incidence we have to take the normal to know the direction of reflected ray. Okay, so this is the angle of incidence, and by making the same angle the light ray get reflected back. See how it is, the reflected rays are also parallel. Okay, so we are getting parallel reflected beam. Clear? So regular reflection takes place on the highly polished surface, and say after incidenting a parallel beam of incident rays, how we are getting? So we are getting parallel reflected beam. So that's why this is also known as specular reflection. And the second type of reflection is irregular reflection. Irregular reflection. This is also known as diffused reflection. Diffused reflection. In this reflection, rough surface. So I am incidenting again parallel beam of light. See, all the incident rays are parallel to each other, right? So at the point of incidence, I am taking the normal. See, for this is the normal and this will be the reflected ray. For this is the normal, this is only reflected ray. So for this is the normal, this is the reflected ray. So how? See, look at the reflected beam, and these reflected rays are going in the random directions. This type of reflection is called irregular reflection or diffused reflection. Is it clear? So now we discuss angle of deviation. Deviation is represented by delta. What is meant by angle of deviation? So angle of deviation is how much angle it is deviated from its original direction. So I am taking a plane mirror. So I am taking a incident ray. So this is the normal at the point of incidence and this is the angle of incidence. Clear? Now what happens after incidence? The mirror will reflect the light. Okay. So this is a reflected ray and this is the incident ray. So this is angle of reflection. Okay. So now if there is no mirror, the incident ray should go along the straight line, right? Because of this mirror, the incident ray is turning back. Is it clear? You understood? So the light ray has to go in this direction. So because of this mirror, it is deviated. Okay. So this is the original direction of the incident ray. So how much it is deviated from its original direction? That is known as angle of deviation. Okay. So angle of deviation, delta. Is it clear? So what is angle of deviation? Angle between original direction of incident ray and reflected ray. Is it clear? So what is delta? Angle between original direction of incident ray and the reflected. This is angle of deviation. Is it clear? So angle of deviation now, let us get the formula to find out the angle of deviation. So here see, this is the incident ray, right? This is the original direction of the incident ray. How it is straight line only, no? What is the angle on a straight line? 180. So delta is equal to, so how you get this angle? How you get this angle? So you take first total angle on a straight line, that is 180 minus, if you subtract these two angles from the total angle, you will get the angle of deviation. You understood? So angle of deviation is the angle between original direction of incident ray and the reflected ray. Okay. So to get this angle, what you should do? You have to subtract these two angles from the total angle. So total angle on a straight line is 180 minus angle I minus angle R. Delta is equal to 180 minus. So you know from the first law of reflection, angle I is equal to angle R, right? So angle I is equal to angle R. So then it can be written as 2 times of angle I. So in terms of angle R, 2 times of angle R. Is it clear? So delta is equal to 180 minus 2I or 180 minus 2R. Is it clear? Now glancing angle. What is meant by glancing angle? The angle made by the surface with the incident ray is called glancing angle. Is it clear? So this is also glancing angle, right? Because if this angle is equal to this, or see, if it is 30, this is also 30, right? Then what will be the glancing angle? See, the normal is making 90 degree with the surface, right? So this is 30, then it will be 60. Okay, so if it is 30, this will be 60. Is it clear? So if these two angles are equal, then these two angles are also equal, right? So 60 and this is 60. Is it clear? Now if it is 60, this is also be 60, right? Because these two are vertically opposite angles. Okay, so vertically opposite angles are equal. So then you tell me angle of deviation in terms of glancing angle. So this is glancing angle, this is also glancing angle. So how many glancing angles are there? 2. So 2 times of glancing angle. Is it clear? So delta is equal to 2 times of glancing angle, and delta is in terms of anguli, in terms of angular. Okay, so now we plot the graph of delta and I. Delta versus I. Okay, so delta is equal to, what is the formula? 180 minus 2 times of angle of incidence. So delta is equal to pi minus 2i. So delta is equal to, I am just rearranging the terms, minus 2i plus pi. So if you compare this with the equation of y is equal to mx plus c, okay, what is the slope here? Minus 2. It is having negative slope, and the y-intercept is pi. Is it clear? So the graph will be, I am taking delta along the y-axis and angle of incidence along the x-axis. So it is having negative slope of minus 2. So the maximum angle of deviation is so the important note point is, you note down, important note, the angle of deviation is maximum for normal incidence. Is it clear? You understood? So the angle of deviation is maximum for normal incidence. So see, once look at this case. This is a mirror, plane mirror. Okay, this is a normal. So I am incidenting a light ray along the normal. See, this is only incident ray. Now you calculate angle of reflection and angle of deviation. See, the incident ray is going along the normal. So what is the angle between incident ray and the normal? Both are on the same line. Then angle between them will be 0. So angle I is 0. If angle I is 0, angular is also 0, right? Angular is also 0. So 0, because angle I is equal to angular. So reflected ray also, like a reflected ray, like it get back in the same way, okay, but in the opposite direction. You understood? So what is delta? Angle between original direction of the incident ray and the reflected ray. So this is the angle of deviation, right? So how much it is deviated? So it has to go along this direction, see, along the straight line. Because of the mirror, it turned back. So how much angle it made? 180. Clear? You understood? So delta is equal to 180. So this type of incidence is called normal incidence. You understood? So when the incident ray is going along the normal, that type of incidence is called normal incidence. So for normal incidence, angle of deviation is maximum, that is 180 degree. You understood? So angle of deviation is maximum, that is 180 degrees. Okay. Now let us solve a question. So I am taking a mirror, and here this is a normal. So incident ray is making 30 degree with the mirror. So you calculate angle of incidence, angle of reflection and angle of deviation. Find out. So here incident ray is making 30 degree with the mirror. So you find out angular and angle of deviation. See. So how much answer? What's the answer? So here see, if it is 30, it will be 60, right? So angle I is 60. If angle I is 60, angle R also 60. Okay, so reflected ray is making 60 degree with the normal. Then delta will be, so what is angle of glancing here? Glancing angle 30. Then two types of glancing angle, right? That is 60 degree. So 2 into 30, 60 degree. You understood? So you can use this formula. So you can use either any formula. Delta is equal to 180 minus 2i. So 180 minus 2 into what is I? 60 degree. So then 180 minus 2 into 60, 120. That is 60 degree. You understood? So what is the delta? 60 degree. So note one important point. So one important point is angle of deviation is maximum for normal incidence. Okay. And the second point is if reflections occurred is more than one, then we add angle of deviation of all reflections along with the sign. Is it clear? See, these two are very, very, very important. Angle of deviation is maximum for normal incidence, and if reflections is more than one, then we add angle of deviation of all reflections along with the sign. And the third point is during reflection, frequency, wavelength won't be changed. Okay, so why frequency? Speed also won't be changed. Okay, so speed, so frequency, wavelength, speed, they won't be changed because after reflection the light is coming back into the same medium, right? Okay, so it's not changing the medium, it is coming back into the same medium. So its speed, frequency, wavelength, so none of them is changed. Is it clear? So for every reflection, intensity will be decreased because after getting reflected, the intensity may be decreased. Is it clear? So these three are very, very, very important points. So now we see how we calculate angle of deviation more than one reflection. Okay, for more than one reflection. So here I am taking the case in which two mirrors are making an angle with each other. So let it be theta. So now I am incidenting a light ray on the first mirror. This is a mirror 1, this is mirror 2. So this is a mirror 1, this is mirror 2. I am taking a light ray, it is incidenting on the mirror 1. So now what happens? You take the normal. So it is the reflected ray, it is falling on the second mirror and again it gets reflected back. Okay, so this is the normal for the second mirror. Now here for the first mirror, what is angle of deviation? See, the angle between original direction of the incident ray and the reflected ray. So this is the angle of deviation of the first mirror. And for the second one, so this is only no incident ray for the second mirror. So this is the original direction of the incident ray and this is the reflected ray. So the angle between this one and this one, this is delta 2. Okay, clear? You understood? So this is the incident ray, this is the emergent ray. Okay. So then what is the total angle of deviation of the system? So how you find out total angle of deviation for the system? So delta net. So net angle of deviation is the sum of angle of deviation by the first mirror plus the angle of deviation of the second mirror. Okay, so along with the sign, see how it is going, angle of deviation by the first mirror. So in the clockwise direction or in the anti-clockwise direction? Clockwise. So plus. This is also in the clockwise. So positive. You understood? And you know one thing, angle of deviation does not depend upon the angle of incidence. Okay, see. So this is the angle of incidence, right? So total angle of deviation does not depend upon angle of incidence. Is it clear? So how you find out total angle of deviation? For more than one reflection, you take the sum of angle of deviation of reflections along with the sign. Is it clear? Let us do a problem on finding total angle of deviation. Okay, so you find out total angle of deviation after two reflections. I am taking 2 mirrors inclined each other by an angle 50 degree. So incident ray, it is falling on the first mirror, making 30 degree. So here angle of incidence is 30 degree. Then you find out net angle of deviation. Find out. So angle of deviation. So you find out angle of deviation for the first mirror. So this is the incident ray for the first mirror, and after falling on the second mirror again it reflected back. Okay, so this is the normal. So if it is 30, this is also 30. Angle I is equal to angular. If it is 30, it will be 60. Okay, so glancing angle here 60 degree. Then what is the angle of deviation for the first mirror? 2 times of 60, that is 120 degree. Okay, so this is the original direction of the incident ray. Okay, so the angle between original direction of the incident ray and the reflected ray is angle of deviation. So delta 1 is how it is going. So in which direction it is turned? Clockwise direction. So clockwise. Okay. So the angle between two mirrors is given 50 degree and it is 60 degree, the total 110. So then it will be how much? 70. Is it clear? So because the sum of three angles in a triangle should be 180 degree. If it is 70, it will be how much? 20. So because the angle between normal and the surface is 90 degree, if it is 70, it will be 20. Okay, total 90. If it is 20, this is also 20 because angle of incidence is equal to angle of reflection. Is it clear? Now what is the angle of deviation for the second mirror? So tell me, glancing angle here 70. So 2 times of glancing angle is 140. So this is also in the clockwise direction. So this is the original direction of the incident ray. So and the angle between original direction, actual direction of the incident ray and the reflected ray is angle of deviation, that is 140 in the clockwise direction. So then what is the total angle of deviation? Delta 1 plus delta 2, that is 120 plus 140, it will be 260 degree in the clockwise direction. Clear? So how many of you got this answer? Let me know in the comment section. Okay, so what is the net angle of deviation? 260 degree in the clockwise direction. Taking an arrangement of 2 mirrors this is M1 and this is M2. So a incident ray is falling on the first mirror. It is making alpha angle. Okay. So the angle between two mirrors is theta. So after incidenting, what happens? It reflects back, right? So the reflected ray falls on the second mirror and again it reflects back. Okay, you understood how many times it reflected? Reflection takes place 2 times. So the first on the first mirror and the second on second mirror. Is it clear? So if it is alpha, this is also alpha, right? Because alpha angle I is equal to angle R. Okay, then what is this angle? It will be 90 minus alpha. 90 minus alpha. Is it clear? You understood? So this is the normal on the second mirror. So let us take the angle made by the emergent ray with the normal is beta. Then it is also beta only, no, because angle I is equal to angle R. Then it will be 90 minus beta. Is it clear? You understood? So now tell me, what is the angle of deviation for the first mirror? Delta 1. So what is glancing angle here? 90 minus alpha. So 2 times of glancing angle. What is glancing angle here? 90 minus alpha. So it will be 180 minus 2 alpha. Okay. What is delta 2? What is the angle of deviation of a second mirror? What is the glancing angle here? 90 minus beta. That is 2 into 90 minus beta. That is 180 minus 2 beta. Is it clear? Then what is the angle of deviation? Total net angle of deviation. Delta 1 plus delta 2. Delta 1 plus delta 2 add. So add both of them. 180 minus 2 alpha plus 180 minus 2 beta. It will be 360 minus. I can take common 2. Then alpha plus beta, right? You understood? So now you look at this. From this triangle, shall I add all these 3 angles to get 180 degree? So I'm adding all these 3 angles. Theta plus 90 minus beta plus 90 minus alpha. It should be how much? 180, right? So 90, 90, 180. So this side, this side, this side. So 180, 180 get cancelled, right? Then theta is equal to, I am sending this minus beta minus alpha to that side. It becomes alpha plus beta. So theta is equal to alpha plus beta, right? So I am substituting theta in the place of alpha plus beta. You understood? So now you got the simple formula for delta net. So what you are getting, again I am writing here, delta net is equal to 360 minus 2 into theta. You understood? So I substituted theta in the place of alpha plus beta. Okay, so I got the formula for calculating net angle of deviation, that is 360 minus 2 theta. So what you understood from this? So net angle of deviation does not depend upon alpha, it is depending upon theta. What is theta? Angle between two mirrors. Angle between two mirrors. Is it clear? You understood? So the angle of incidence, see, it does not depend upon angle of incidence. The net angle of deviation is depending on the angle between two mirrors, theta. Is it clear? So what is delta net? 360 minus 2 theta. Okay. So now let us do a problem. So I am taking two mirrors. So these two mirrors are perpendicular to each other and I am incidenting a light ray. Okay. So you find out net angle of deviation after two reflections. After two reflections. Tell me what is the angle of, what is the net angle of deviation? So net angle of deviation is 360 minus 2 theta, right? So 360 minus 2 into what is theta? Angle between two mirrors. How much? 90. So 360 minus 290 is 180. 360 minus 180, 180. You understood? So what is the net angle of deviation? 180.